Okay students, today I am taking the one more model in exercise 7.2. We are completed the different models. In this is the last model of this exercise. In this exercise, second question, trisection. I given the formula for the trisection as well as and one example also given to you. Same model of that one here. A line segment, given line segment divided into four parts. So how can you find the intersection points of the 3 points? 2 points are given, P1, P2, P3. Then you are taking 3 points is divided into four. Always in trisection are in 4 points. You need to remember one important point, that is divisions must be equal. They didn't mention in the question how much ratio. You need to understand 1 1 1 1 only. In trisection also m1 equal to 1, m2 equal to 1, also remaining part also 1. So there is 3 parts are there. First, there is no midpoint. Compulsory we are using the section formula. So here you see it is very easy question. Here 4 parts are there. A and B are the given points, clear, and P1, P2, P3 are the dividing points. So here important thing is 4 parts are there. Here P2 is the midpoint. So simple, without using the section formula, by using only midpoint formula, we can find the points of P1, P2, P3. I will explain to clear this. Then afterwards, I will explain one sum on the base of this. Clear to you? Use step 1 what to do. All points are equal measurements one another. That is P2 is the midpoint of AB. So you remember the midpoint formula I derived in the first at the time of section formula, special case m1 equal to 1, m2 equal to 1. That is here P2 is the mid formula of A and B. So the formula we can use here, P2 equal to x1 plus x2 by 2 comma y1 plus y2 by 2. This is the midpoint formula of A and B, any 2 points. So next step, you are written the formula, we are following the substitutions also here. So step now P1 is the first step over. P2 point you are find out by the midpoint. Then how to find the P1? Now you see, after finding the P2, you have the point P2 now. Now P1 is the midpoint of A and P2. Clear to you? So again you are finding the P1 point equal to midpoint of A and P2. A point is there, P2 already you find out. You are taking the midpoint formula, you will be get P1. Then step 3, now P3 point. P3 is the midpoint of what? See, P2 and B. P3 is the midpoint of P2 and B. So P3 for equal to, we can write the midpoint of P2 and B of x2, y2. Coordinates already B is there and P2 already we find above. With this one we can find the P3. Clear to you? Then I will see. Here I will take one example here. You see, this is exercise 7.2, question number 9. Up to 7 was over. 8 is the same model only. 8 here nothing is there. The ratio is given. You not to take directly whatever ratio is given m1 and m2. You will be take 3:4 because 7 minus 3 is 4. So m1 equal to 3, m2 equal to 4. Like that you need to take in 8 sum. 9 is same based on the 4 parts. You see, find the coordinates of the points which divide the line segment joining A, B into 4 equal parts. Clearly given. You see the diagram as same as here. A and B are the points given. You are going to find the points P1, P2, P3. Okay, clear. All measurements are equal. Length of all segments are equal. So AP1 equal to P1, P2 equal to P2, P3 equal to P3. This is the meaning of length of the all parts equal. So obviously P2 is the midpoint of AB. I explained in the derivation of the formula here, right? So here P2, midpoint of A and B. A is given minus 2 comma 2, B is given 2 comma, clear, 2 comma 8. So the average of the x coordinates gives your x coordinate of the P2 and average of the y coordinates will be give the your midpoint y coordinate. See, minus 2 plus 2 upon 2, x1 plus x2 upon 2, comma 2 plus 8 upon 2, that is y1 plus y2 upon 2. It gives to you 0 comma 5. Minus 2 plus 2 is 0, upon 2 is 0, 8 plus 2 10 upon 2 is 5, 0 comma 5. So now you are going to find the point P1. P2 already you know 0 comma 5, and A also you know minus 2 comma 2. Now P1 is the midpoint of A and P2. Clear to you? Now x1 is minus 2, x2 is 0, y1 is 2, y2 is 5. So according to that, again we are using the midpoint formula, x1 plus x2 by 2 minus 2 plus 0 upon 2 comma 2 plus 5 upon 2, that becomes minus 2 plus 0 upon 2 is minus 1, 2 plus 5 7 upon 2. Now you got the point of P1. First we are find out P2, then P1, and B already is there. P3 we are going to find. Now P3 is the midpoint of P2 and B. P2 already you have it, that is 0 comma 5, and B you have it, that is 2 comma 8. Both points you had it, right? So according to that, x1 is 0 and x2 is 2, y1 is 5, y2 is 8. So again midpoint of P2B is 0 plus 2 upon 2 comma 5 plus 8 upon 2, that is 2 upon 2 is 1, 5 plus 8 upon 2 is 13. So 1 comma 13 by 2. So now clearly P1, P2, P3 we find out. P1 is 0 comma 5, P2 is minus 1 comma 7 by 2, and P3 is 1 comma 13 by 2. Here we didn't use section formula. If you want to use, you can use also. Always you are taking 1 is to. First point 1 is to 3, second point 2 is to 2, midpoint only, third point 3 is to 1, fourth point 3 is to 1, the 1 2 3. Clear to you? So this is a best sum based on the 4 parts. Okay, you see next question, last question of this exercise. Find the area of a rhombus if its vertices are given. Okay, so generally we can use the formula of rhombus. Different formulas we can use: base into height, half into product of diagonals, I means half into d1 into d2. Clear? These are the formulas. So here we are using that here distance formula. I mean, if you know the length of the two diagonals, you can use this formula. So here you see I make the color different here. Blue color will be one diagonal, that is dB, and red color will be the AC of another diagonal. Clear to you? These are the two diagonals. If you know the length of these two diagonals, you can substitute in the formula, you will be get. See, first I want to find the diagonal AC. So how to find the length? By distance formula. Starting 7.1, first sum we did, I derived the formula of distance formula, right? That we are going to again here. So this, what is distance formula? Square root of x1 minus x2 whole square plus y1 minus y2 whole square. Here x1 is 3 and x2 is 1, y1 is 0, y2 is 4. By substitution, AC equal to square root of minus 1 minus 3 whole square plus 4 comma minus 0 whole square. Here minus 3 minus 1 is minus 4, minus becomes 4, 4 square is 16, again 4 square is 16. So 16 plus 16, here 32, I mean 16 to the 32, that 16 comes out, or 2 16. Clear to you? 16 comes out becomes 4, 4 root 2 will come. So now I am going to find the diagonal BD. So BD here, B point is 4 comma 5, D point is minus 2 minus 1. So x1 we can take minus 2, x2 is 4, and y1 is minus 1, y2 is 5. So by using the distance formula, BD we can find, that is minus 2 minus 4 whole square plus minus 1 minus 5 whole square equal to square root of minus 2 minus 4 is minus 6, minus 6 whole square is 36, minus 1 minus 5 also minus 6 whole square is 36. 36 is what? 72, square root of 72. So 36 2s are 36 comes out becomes 6 root 2. Now have the length of the AC and BD. AC is the diagonal 1, BD is the diagonal 2. So here product means multiplication. Now you write area of rhombus equal to half into AC into BD. I mean half into diagonal 1 into diagonal 2. So half into 4 root 2 into 6 root 2. So you can cancel 2 1s are 2 2s are. Then here root 2 into root 2 becomes 2. Clear to you? So 12 2s are 24 square units. Why I written units here? Square units, no units are there in the question. I mean coordinates already we are going to plot on the graph. On the graph paper all square units are there, so you can give the measure of square units. Clear to you? It is a best example based on to find the area. So like this we can find the area of triangle, and different areas also find in different ways. So after this we are going to find the area of the triangle on the basis of coordinate geometry, not like half into base into height. Clear to you? Thank you very much.